Welcome to a trapezoidal rule example. So recall that the definite integral from a to b of f of x dx could be approximated with n trapezoids. And we wound up getting that this is approximately delta x divided by 2 times f of x0, f of a essentially, plus 2 times in parentheses f of x1 plus all the way up through f of xn minus 1, end parentheses, and then plus f of xn and the second set of parentheses, where delta x was b minus a divided by n, and our x sub i's were a plus I times delta x. So our job here is to go ahead now and approximate the definite integral from 0 to 4 of e to the negative x squared dx by using the trapezoidal rule with 8 equally spaced subintervals. So 8 equally spaced subintervals, this is telling us that our n is equal to 8. Our a is the lower limit of our definite integral or lower bound, so our a is 0. B is the upper bound, so our b is 4. So we have n equals 8, a equals 0, and b equals 4. So working through, we also have f of x is the function inside our integral. That's our e to the negative x squared. So working through our formula, the first thing we need is our delta x. So we have delta x was b minus a divided by n. So we are looking at 4 minus 0 divided by 8, otherwise known as 1/2 or 0.5. Next thing we want to do is find our x sub i's. For 0 less than or equal to I, less than or equal to n. So we're going from 0 to 8. X sub 0, or in our formula is xi is a plus I times delta x, or 0.5, sorry, a was 0 plus I times 0.5. So essentially each additional xi, we're just adding on another copy of 0.5. So we have x0 is 0, x1 is 0.5, x2 is 1, x3 is 1.5, x4 is 2, x5 is 2.5, x6 is 3, x7 is 3.5, and x8 is 4. Note our x sub n is b and our x sub 0 is a. So just note x sub 0 should always be a, x sub n should always be b. At this point, we now need to find the function values at each of these x sub I. So our next step is to find f of x sub I. So f of x0 is just f of 0, which is e to the negative 0 squared, otherwise known as 1. f of x1, we will be looking at f of 0.5, or e to the negative 0.5 squared. I'll come back and fill in the actual values in just a moment. F of x2 is f of 1, or e to the negative 1 squared, otherwise known as 1 over e. F of x3, we are looking at f of 1.5, or e to the negative 1.5 squared. F of x4, we are looking at f of 2, or e to the negative 2 squared, otherwise known as 1 over e to the 4th. F of x5, we are looking at f of 2.5, or e to the negative 2.5 squared. F of x6, we are looking at f of 3, or e to the negative 3 squared, otherwise known as 1 over e to the 9th. F of x7, we have f of 3.5, or e to the negative 3.5 squared. And finally, f of x8, we are looking at f of 4, or e to the negative 4 squared, otherwise known as 1 over e to the 16th. So now let's go ahead and fill in approximations for these, going out, say, 5 decimal places for each. So filling in these values, our f of x0 is 1, as we found. Our f of x1 would be 0.77880, and then it continues on from there. Our f of x2, or 1 over e, is 0.36787, and then we continue on from there. Our f of x3, we are looking at 0.10539 ... F of x4, we are looking at 0.01831 ... F of x5, we are looking at 0.001939 ... F of x6 at 1 over e to the 9th, we are looking at 0.00012 ... For f of x7, we are looking at 0.00004 ... going out 6 decimal places there. And f of x8 will have 0.0000001 ... So as you can see, what we're adding on for our, as those we make our way towards 4, we're adding on teenier and teenier and teenier areas for those, or heights. So at this point, we have all of our x0, or f of x0 through f of x8. From here, we just have to plug into our formula. So from here, we plug into the formula. To approximate a definite integral from a to b, or from 0 to 4, of e to the negative x squared dx. So this was approximately, again, we do delta x over 2 times f of x0 plus 2 times f of x1 plus all the way up through f of xn minus 1. So in this case, f of x7, and then end up parentheses, no more times 2, we add on another plus f of x8. Our delta x was 0.5. So we are looking at 0.5 divided by 2 times f of x0 was 1. Then we have plus 2 times f of x1 was 0.77880 dot dot dot. And then I'm just going to do plus dot 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 plus. Our f of x7 was 0.000004, 5 zeros if I added too many. And then we have an additional plus 0.00000001. Not being multiplied by the 2. So if we go ahead and add all of these together and we do our multiplication, we wind up getting 0.5 over 2 becomes 0.25. Then we have 1 plus that 2 times the entire thing in the we have 2 times the inner parentheses winds up totaling up to 1.27245 dot dot dot. And then we have plus our 0.00000001 dot 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 on the end. And if we do this final computation, we wind up getting that our definite integral is approximately 0.88622 dot dot dot. So this is using the trapezoidal rule with 8 trapezoids. As you can see, it gets rather annoying. Feel free to use calculators, Excel, anything you want to do these computations. You don't have to do it all by hand. But you should know how the rule works.